like most of the class is not here. Good morning, good morning. So today we're going to be doing a review of some chapter 5 material that we did last trimester, whether that been winter trimester or fall trimester. So we're going to go ahead and take some notes and get started with that. Okay. So here, let me close this up and let's take some notes. So what we're going to do is we're going to go section by section, and I'm just going to highlight all the important things that you guys need to do. And then if you guys have questions, as always, use chat. You guys seem to understand how chat works. You can send a private message or a public message, and then or you can turn on your microphone and ask that way. Okay. So again, we're going over a review of all the chapter 5 stuff, and then you're going to have an assignment tonight as well. So remember, your assignment tonight is going to be on Big Ideas Math. So make sure you guys turned in those first 2 assignments on Google Classroom. From now until the end of this trimester, all of your homework is going to be on Big Ideas Math. So there won't be assignments on Google Classroom anymore. Okay, so all your assignments will be on Big Ideas Math from now on. So when you go to do your assignment at the end of class, an assignment will show up in Google Classroom, but it's just a link to Big Ideas Math. You're going to log in, and there will be an assignment there, and it's going to be posted at the end of class. Okay? And as always, if you guys have questions, you can email me or come to my office hours as well. So first thing we're going to do, we're going to take a look at what the heck did we do in 5.1. Okay? And the big thing in 5.1, there was really only one thing, and that was the triangle sum theorem. Okay, so the triangle sum theorem. Okay. Now, there's a couple of things that we need to remember in the triangle sum theorem, right? So basically, if I was going to write this as like a visual, right, it would be given any triangle, we're going to have angles 1, 2, and 3. Okay. And then we know then that angle 1 plus angle 2 plus angle 3 is going to equal 180 degrees. Okay. Now, the book is confusing sometimes with this. So I just want to add in, especially in your homework, the book sometimes will call this, so I just want to give a different example of this. So in the book, sometimes they'll have 2 triangles. So let's say I have this triangle and this triangle. Okay. And they might say, okay, this is 40 degrees. Oh, this blue pen is dying. I'm going to switch to a black pen. We have 40 degrees maybe here and 40 degrees up here. Okay. And then we might have 60 degrees here and 60 degrees here. Oh, I'm glad that you're here. Remember, everything you missed is going to be on YouTube. So we're going to have, so we have that. So let's call this X. No, let's call this theta. And let's call this phi. Okay. So one property that you might not have learned in your geometry class, I know I didn't talk about it with my students because we didn't have time, but one thing to look at, so if we have 40 and 60, and notice how this is 40 and 60, right? 40 plus 60, that is 100, right? I had to double check my math really quick. That would have been embarrassing, right? So do we all agree that 40 plus 60 is 100 degrees? Okay, we're good there. So thank you, I appreciate that. So yeah, so according to the triangle sum theorem, what does theta have to be? Doesn't this have to be, doesn't that have to be 80? Right? So this would have to be 80. All right, and then the same thing down here. This has to be 80. Okay, again, by the triangle sum theorem. Okay, so both of those have to be 80. But the book calls this says that, this is what the book says. Oops, I can't use that pen. It says that the angle theta must equal this angle, and they call it the third angle theorem. Okay, which is confusing. Like, why can't you just call it the triangle sum theorem? Well, it's slightly different. It's just that since you know two of the angles are the same, then the third angle also has to be the same. Does that make sense, guys? So I'll put that in a little notes, right? If two angles are the same, if two corresponding angles are the same, so if two sorry, my handwriting's not very nice today, is it? If two corresponding angles are the same, the third corresponding angle okay, so the third corresponding angle is the same as well. Or I should say are the same. Man, my handwriting is exceptionally bad today. I'm so sorry, guys. My hands are really cold, and it's really hard to write. So this is what the third angle theorem says. If two corresponding angles are the same, the third corresponding angle is the same as well. And that's just something that, like, you're like, Kreft, I don't remember that from my last geometry class. I mean, I didn't teach it in my class because I ran out of time, and there's a good chance that your geometry teacher that you had for first trimester didn't teach it as well. So I just want to throw that in there. It's going to show up in your homework. So I just wanted to show you what it is. So it's just the third angle theorem, right? So if two corresponding angles and triangles are the same, then the third one has to be the same as well, right? Because we know what these two add up to, so these two have to be the same thing, okay? And that's called the third angle. And that's not a reference to being the awkward person in a date. You know what I mean? Like when you hang out with your friends and they're all like touchy and you're like, ooh, this is awkward. I'm just a third wheel. Has nothing to do with that. It is just the third angle theorem. It's just if two angles are corresponding and congruent, then the third ones are going to be congruent as well. Okay? All right. Does anybody have questions about that? I know I said review today, but that is the only thing that's new. Are we okay with that? So triangle sum says the angles in a triangle add up to 180, but then there's this third angle theorem, which is in math we call it a corollary. It's not really its own thing. It's just it builds off the triangle sum. So if you know two corresponding angles are the same, then the third angle has to be the same as well. Thank you guys for using chat, by the way. I really appreciate that, because if you guys don't give me feedback, I don't know if you guys are getting this. If you're just playing video games, or if you're just picking your nose, like, and you got like a really big one that when you pull it out, like it just keeps like coming and coming, right? It's like the good one, you know, that you save for later. Maybe you put it behind your ear. All right, so that's 5.1. Okay, let's get to 5.2. Right, and all we're doing in our notes, I'm just reviewing things, right, that we're doing that. So remember with this, we found missing angles, right? So again, like I just did an example. If these add up to 100, this has to be 80, right? Because they add up to 180. All right, so now let's talk about 5.2. 5.2 is special triangles. I'm just going to abbreviate because I'm lazy and my hands hurt. Okay, so 5.2 is special triangles. So we have two special triangles that I just want to talk about really quickly as a review. Okay, the first one is isosceles. Okay, so isosceles has the most going on. So if we look at an isosceles has two congruent sides. Okay, so an isosceles has two congruent sides, and remember we use kind of like these tick marks. So I put 2, but we could put 1, 3, 4, right? So it's just basically it's just a symbol showing that these two sides are the same. Okay, and then we also have to remember that it's not just two sides, right? This is called the base. These are called legs. Okay. There's also base angles, right? And if two sides are congruent, then the angles opposite of those congruent sides are also congruent, right? And these are called base angles. Okay, so it has two congruent, and I'm going to call them base angles here because that's what they are. Okay, and they are opposite of the congruent sides. Okay, so again, just doing a review of, right, we ended the trimester, and really this review is especially for people who had geometry that first trimester, because it's been a while since we've done math, right? So this is a shout out to you guys. Okay, so we have two congruent base angles. They are opposite of the congruent sides, and vice versa, right? So if you have congruent base angles, then the sides are going to be opposite of those congruent base angles. And then last but not least, this little angle up top here, right? Oops, I shouldn't do that. Don't do that. All right, I just colored it in, so that means nothing. So this angle up here means vertex. Don't do what I just did there. It's just supposed to be, that's called the vertex angle. Filling it in means nothing. That's just me making a mistake and trying to cover up for myself because I'm writing with pen. So there's the vertex angle. All right. So that's it. That's an isosceles. It has two congruent sides and it has two congruent base angles. Now, how we're going to be using this trimester is we're going to be proving triangles or parts are congruent. So one way that we can use this is definition of an isosceles triangle. Okay. Now, I don't think that we're going to be using this anytime soon, but I'm just going to write that down. So this is definition of isosceles triangle. Okay, so like if this was A, B, C, I could say segment AB is congruent to segment CB, or angle A is congruent to angle C. Okay, so that is definition of isosceles. So if we were trying to prove that certain parts were congruent, if we know it's an isosceles, then we know these things to be true. Okay. I know you guys, this is like super exciting stuff, right? Like when I woke up this morning, I was like, oh my gosh, I get to talk about isosceles triangles. It was pretty crazy. I couldn't control myself. I was running all around the house like a madman. Because I am a madman. Okay. So that's basically everything we need to know about isosceles. And hopefully you're writing down all your notes so you have this in one place. Okay. All right. All right. I'm gonna flip over to the other side. Are you guys doing okay? Am I going at an okay pace? Okay. All right. So then the other special triangle we have is equilateral. Okay. So an equilateral triangle has less going on, but it's important to note the root word equa, right, means the same, and then lateral is a root word for side or straight. So it's equal straights. So that's the root words for that. So equal, the same straights means the same sides. So if we draw an equilateral, it might look something like this. Okay. Notice how I put a tick mark on all three sides. So all three sides are congruent. . And then the other one, and this stems off isosceles triangles, right? So if opposite angles of congruent sides are congruent, well, all these sides are congruent, so all the angles are congruent. And they turn out to be 60 degrees. Okay, so all angles are congruent. And they're all 60 degrees. Because they have to add up to 180, right? So if they add up to 180, 60 plus 60 plus 60 is 180. It's the only way that they can all be the same and add up to 180. You know what I just realized? I mislabeled this here. This is 5.4. Sorry about that. Special triangles were 5.4. Not a big deal. I'm sure none of you care. I care though. Okay, so that was it for 5.4. It was just those two triangles. Okay. All right. Now the real 5.2, I feel like Slim Shady now, right? Well, the real 5.2 step on up. So 5.2, this was all about congruent shapes. Okay, and that's and I'm just gonna I saved this one for last. Sorry, I went out of order there. I saved this one for last because this is what your homework is going to be off of, because out of the chapter 5 sections, 5.2 is the most. So you're going to have a homework due next class on 5.2, and it's 1, 2, 3, 4, 5 questions long. So you guys got this. Okay. Not a long assignment. Just want to make sure you guys remember congruent shapes. So we have to remember for triangles. Okay, so for triangles, there are 6 parts, right? So there are 3 sides, and there are 3 angles. Okay. So if I have a congruency statement, let's say I say triangle ABC is congruent to triangle TRY. Okay. Then that means there are 3 sides that are corresponding and congruent, and there are 3 angles that are corresponding and congruent. So I can, starting with the angles, list corresponding congruent angles. So for example, order matters. So if order matters, right, and this is, we have 1, 2, 3, and 1, 2, 3, then that means that this first letter goes with the second letter. So I have angle A is congruent to angle T. And why is that? Because the triangles are congruent, which means all 6 parts are congruent, which means angle A is congruent to angle T. Okay, and this should be reviewed. So I'm not going like super in detail of this, and my notes are super light, right? But again, this is just supposed to be like, oh yeah, we did go over that, okay? So then I can keep going here. The second one, angle B, is going to be congruent to angle R. And angle C is going to be congruent to angle Y. And again, if you guys at any point just stop me, you can be like, man, Kraft, it's been a long time. I don't remember this. Or Kraft, like my last teacher taught me, you know, something a little bit different. Is this okay? Like, feel free to ask, okay? That's what this is all about. So make sure you guys, if you have questions. Now for sides, it gets a little bit more difficult. So for sides, we're going to be doing segments, right? So segments, if you remember, take 2 letters. So I don't need a picture to do this. I can just use the first two letters in this segment. So I can say segment AB. Okay, that's a segment on triangle ABC. So, and again, because order matters, I don't need a picture. I can just say, hey, segment AB goes with TR. Right? Because check out this list. This is why we do the angles first, right? If A is first, then the first letter has to be T. If B is second, then the second letter has to be R. Pretty cool, and you can do it without a picture, right? So if I use the first two letters, I might use the next two letters, right? 2 and 3. So that would be BC. And again, you don't have to, right? For example, I can write this as BA. That just means this would be RT. And I can write this as CB. That just means this one would flip as well. So again, B comes first. B goes with R. Right? Just as B went to R here. And then C goes with Y. Like that. How are we doing so far, guys? Is this all striking a chord with you guys? You're like, wow, like, yeah, this makes sense. We're doing okay. All right. And if you guys have any questions, right? It just takes one question, then I'll answer it, and I'll slow down and we'll go over it, okay? So then the last one, so we did the first two and the last two. So the last combination is the first and the last, right? That's the only combination we don't have. And then we just remember, hey, A goes with T and C goes with Y. Okay, so again, when we're talking, now this is congruent triangles, right? If we were talking, well, thank you, I'm flattered, I appreciate that. So if we're talking, now this is only for triangles, right? So this is only for triangles. If we had, you know, like a four-sided shape, then there would be more parts, right? There would be 4 sides and 4 angles. If it was a pentagon, then it would have 5 sides, 5 angles. If it was a hexagon, well, then you're just cursed. And that sucks, right? That sucks. Okay, so again, this is just a review day, so I'm just going over basic stuff. If I do touch on something and you're like, whoa, I don't know any of this, say something and I'll go more in depth. I'm not like teaching, I'm just reviewing. Okay? All right. Now, and you guys remembered like and you're gonna have problems. So again, your homework tonight's gonna be based off 5.2. So like we might have something like this and like this, and like, do you guys remember doing this? This is like 58. This is like 70, and this is like 58, and this is like X, right? And like this is Y plus 2, and this is 72. I don't know. I'm just making up numbers, right? Right? Do you guys remember doing this? And then like, if you look up the corresponding parts and you set them equal, is that like coming back? Do you guys want me to do an example of that? Is that something you guys want? I can do an example. Does anybody want me to do an example of that? Here, I'll look up an example. Yeah. I'll look up an example. It's not a, what's it called? It's not a democracy. It's a, here. So sorry about that. Let's do an example of this together. Okay, we're gonna do an example. We'll do a proper example. So I'm going to, if you guys could draw these down as well. So this is gonna be D, E, F, and G. And then I'm gonna have N, P, Q, and M. So if you guys could get this down, we're gonna yeah, and hey guys, and thank you for the feedback. Like, I appreciate people sending me direct messages and be like, what the heck are we doing? I don't remember any of this. Dude, that's why I'm here, right? This is good. I appreciate you guys. That's why I'm here. I'm here to help. Okay, so I'm gonna go ahead and add some stuff to this. So I'm gonna have 8 feet up here. It's a lot of feet, right? Probably smells really bad. And then 102 degrees here, 84 degrees here, 68 degrees down there. And then over here, angle P, I'm gonna have I don't want it to be that complex, so I'm not. I'm going to say, let's say 3 plus 2y, and then I'm going to put a degree symbol so we know it's an angle. And then I'm going to have x minus 2. And then I'm going to put feet next to it so we know it's a side. And then we need one more piece of information, and we need the congruence statement. So DEFG is congruent to QMNP. So there's the whole problem. Take a couple seconds and write that all down. I know it's a lot to write down. Yeah, I mean, if you want this in your notes, you should write it down. Absolutely. Right? And remember, everything we do is open note. So, right, your homework assignments are open note, your tests are open note. So you should always be taking notes. Now, if you ever don't get something down in your notes, all of my class videos are posted to YouTube. So let's say like, oh man, you know what? I just didn't get down that example. You can always go back later and get the example down from YouTube, right? And I make my assignment short, so you guys have lots of time outside of class to do that as well, and I do that on purpose. Okay. All right, and then a question like this would say solve for x and y. So solve for x and y. So we got two congruent shapes. How do we know they're congruent? Because we have a congruence statement. Okay. So the first thing we want to do is like, okay, where's our x, right? So it looks like our x is down here. It's a side. So it's on side MQ. So the first thing I'm going to do is I'm going to look at my congruence statement. And I'm going to say, where's MQ? So MQ is right here, right? It's the first two letters. Okay. So right off the bat, I'm going to know that segment MQ is going to be congruent to, well, MQ is the first two letters. So then that would be ED. Okay. So let's take a look. ED is 8 feet. So I know that MQ is x minus 2. And then we're talking values, so we can talk equal, right? We only do congruent when we have shapes. So as soon as I go to values, I can say equals, and I can say 8 feet. And then boom, you're like, crap, I got this. It's just algebra now, right? So I'm gonna go plus 2 on both sides. And I'm gonna have x equals 10. Hopefully I'm not going too fast. Are you guys doing okay? Are you guys okay with this? Hopefully this is helpful. Right, we're going to be doing a lot with congruent shapes, so it's really important. That's why our review assignment today is at 5.2. There's even going to be a little proof, and I'll go over reminders for proofs at the end of this. Okay, there's one proof on your assignment. Okay, so that's how we solve for x, right? Again, using that congruency statement. To solve for y, I'm going to look where y is, and it looks like y is on angle P. So let's see what angle P is congruent with in the other shape. So P right here, right? P is the last letter. So the last letter here is G. Okay, so it's going to be angle G. So I know that 3 plus 2y is going to be equal. Again, as soon as I go to values, I go to equal, and then 84 degrees. Okay, so then we're going to have to bust out that algebra skill that we have. I know you guys have it, right? So I'm going to get rid of addition, subtraction first. So I'm going to subtract 3. I'm going to get 2y equals 81. I'm not going to lie. I know 9 squared is 81, but half of 81 is going to be, it's a decimal. Okay, so I'm going to have divided by 20. Divided by 20. I can't speak, apparently. I'm going to divide by 2, and I get y equals 40.5 degrees. Okay. Okay, so that's an example of how we use congruence statements in solving for missing pieces. Okay. You guys doing okay there? Does anybody have any questions? And as always, guys, if you guys get to the homework and you're trying out the homework and you're confused, you can always send me an email, or you can come to my office hours and we can work on it, right? Because I know how that feels, right? Like in class, everything is making sense, but then in the homework, it's like slightly different and you're thrown off a little bit. So just remember, I'm always here to help you guys out, okay? All right. Noise. Okay, so this trimester, so now that we did 5.1, 5.2, 5.4, this trimester we're going to be really focusing on proving triangles congruent. Like, how do you prove it, right? And there's got to be a shorter way. So we talked about how there's 6 parts for triangles. There's got to be a shorter way than having to do this every time. And that's what the first part of this trimester is going to be about. It's going to be, how can we prove triangles are congruent with not having to do all this work, right? So we're going to need rules. We're going to need rules to show angles are congruent. We're going to need rules to show sides are congruent. So what I'm going to do is I'm going to give you guys a list of all the geometry rules that we have so far that are going to be helpful, and a little example of what they look like. So this is really important for you guys to have down in your notes, because it's going to help us for the rest of the next couple of months with our proofs. So you'll always be coming back to this list. Does that make sense, guys? Really important. So important. Oh my gosh, it's such a big deal. All right, so let's do geometry rules. Geometry rules to use in proofs. Now, you guys learned a lot of these first trimester geometry. Second trimester, we're going to be adding a few more. So I'm just going to go through like, hey, things that you should already know that we can use in proofs. Okay? And I'm just going to go through, and if you guys have questions, just say something and I'll help you guys out. Okay? All right. We have complementary, or yeah, complementary angles. Okay, complementary angles. So if you were in my class first trimester, we talked about looking at the P, right? If you think of P as 90 degrees, right, then you'll always remember complementary angles, they add up to 90 degrees. So it's, let's do red here. So it's 2 angles that add up to 90 degrees. Okay. Complementary. And the reason why I say think of the P as 90 is because then when we take a look at supplementary, I have a really funny story about supplementary, but we don't have enough time for me to tell it, and that makes me really sad. See, it has 2 P's. So if we think P as 90, then 90 plus 90 is 180. So this is just 2 angles that add up to 180 degrees. Okay. Now, these can be used to write equations, right? And I'll show an example right over here to the right. So here's an example. So an example might be like angle 1 and angle 2 are, oops, I'm running out of room here, sorry, are complementary. Okay, so here's the example. So it's angle 1 and angle 2 are complementary, and that's given. Here, I can make like a little proof. Okay. Then what I can say after that is if angle 1 and angle 2 are complementary, that means that they add up to 90. So I can say angle 1 plus angle 2 equals 90 degrees, and that is the definition of complementary. Uh-oh, I just froze. That's not good. Woo! If I'm freezing on my end, oh yeah, we can slow down just a little bit. Sorry about that. But my screen just froze. So I must have frozen on your bit. Okay. So again, this is just an example. So if you're told that angles are complementary, that means they add up to 90. So that's the definition of complementary. I left out an M in here, didn't I? And an E. There we go. Just didn't have enough room, so I thought I could squeeze it in by leaving some letters out. English teachers hate me. Okay, so again, we have complementary, supplementary. One adds up to 90, the other one adds up to 180. The one with the more p's adds up to 180. Angle 1 plus angle 2 is equal to 90. An example, right? This is just an example of using that. What do we got? We got 11 minutes left. No, we got more than 11 minutes. We got 12. We got 13 minutes left. I can count, I swear. Okay, I hope that you got this down. All right. So next up, okay, so we have complementary and supplementary angles. What else did we have? We had midpoint and bisector. Hopefully this is ringing a bell. Midpoint and bisector. Okay, they both. Okay, so midpoint and bisector. I need to slow down. Midpoint and bisector. So what do these do? Right? They both cut something in half. So they make two equal parts. Okay, they make two equal parts. And then in parentheses, if you really want this, you can say by cutting it in half. By cutting in half. Okay, so it makes two equal parts by cutting in half. So if you have a midpoint or a bisector, two things are congruent, whether they be sides or angles. Okay, and I'm just going to do two visual examples because I don't have a lot of time left. I have to get through everything. So I'm going to just do two visual examples here. So here's a couple of examples of what this looks like. So if I have A, B, and C on a segment, then I could say if C is the midpoint of segment AB. Okay, so if C is the midpoint of segment AB, put a comma there. So if C is the midpoint of segment AB, then segment AC is congruent to segment BC. Okay, so notice how just by having a midpoint, I have two equal parts. Okay, and that can show up as definition of a midpoint or definition of bisector. Okay, my other example, I just want to do one angle example really quickly. So I might have A, B, C, and then D. And again, hey guys, I have to speed things up a little bit. So if you don't get all of these notes down, I encourage you to go back to YouTube and fill out your notes. Okay? So if we say ray BD bisects angle ABC, So if ray BD bisects angle ABC, then angle ABD will be congruent to angle CBD. Okay. So those are examples of using midpoint and bisect, right? I'm sorry guys, 50 minutes is really not a lot of time. So I got if we're gonna have examples, I have to do a little bit. So if you didn't get that down, come back to it, watch the YouTube video, and you can finish your notes that way. Okay. Okay, the next big one is transitive and substitution. I put them together because they're almost always, like, the line between them is so thin. They're basically the same thing. Okay, so basically, if you have A equals 6 and A plus 7 equals X, so what's 6 plus 7? I'm not thinking. 6 plus 7 is 13. Then X equals 6 plus 7. Okay. Okay. Another example of this might be if A plus B equals 180 and C plus D equals 180, then A plus B equals C plus D. Sorry, it wasn't on there. Again, sorry guys, this isn't a lot of time, but I want to give examples for everything, so I only have 7.5 minutes left. Okay, so that's transitive and substitution, just different examples of that. Next up, I have reflexive. This one's going to be big. We didn't use this one a lot first semester or trimester, but we're going to be using it a lot this trimester. So reflexive means something equal to itself. So it means something equal to itself. So I'm going to give 2 examples of this. Okay. So again, at this point, hey guys, if you missed something in the notes, just check out the YouTube. I just don't have enough time. I have to get through everything, and I'm really sorry. I know that's not good teaching, but I have 50 minutes. So reflexive, something equal to itself, and that's why I post these videos to YouTube. Something equal to itself. So I have 2 examples of this. One would be, let's say I have a triangle like this, and then a triangle like this. I'm just going to label this as A, B, D, and C. Now there's 2 triangles, right? There's triangle 1 and there's triangle 2. So you can think about this as a room in your house, right? Rooms often share a wall. Now that wall is the same wall for both rooms. That is, segment BC is congruent to segment BC. Okay, that's reflexive. Okay, so something is congruent to itself. So that is an example. Another example would be what happens if we have a big triangle, but then a smaller triangle in here. So I can label this as A, B, C, D, and E. Okay. So you have a big triangle, ACE, but then you have a smaller triangle, BCD, that's laying on top of it. You guys see how this smaller one is like laying on top of it? You can't really do that with two-dimensional, right? But the whole point here is, you guys notice how angle C is the same for both those triangles. It's ACE and it's BCD. So here I can say angle C is congruent to angle C by reflexive. Oh my gosh, yeah, I need to get going, guys. I'm so sorry. I have to speed up just a little bit. If you don't, just leave space in your notes if you're not getting this all down, and come back, pause the YouTube video, and you can get it all done. Okay, we already went over the triangle sum theorem, so I'm going to skip that. So the triangle sum theorem, or the third angle theorem, we already wrote notes down on that. But now I want to talk about parallel lines. Okay, so if parallel lines, then corresponding angles are congruent. Okay, so what does that look like? Well, we have parallel lines, and we have a transversal. So corresponding angles means same location. So if this was in the upper right, then it would be in the upper right down here. If we had a box in the upper left, it would be a it would be a box in the upper left. If we had a filled in box, see how I'm recovering this, then this would be a filled in box. If this was a circle, this would be a circle. Okay. What else do we have? We have, if parallel lines, then alternate interior angles are congruent. Now I'm gonna run out of room here. Sorry. So alternate interior. What do we have? Got to make these lines parallel, right? So alternate interior. Remember, interior means inside. So inside the parallel lines. So it's going to be alternating like this and like this. So those would be alternate interior angles. And again, sorry guys, I'm well aware that I'm going too fast. Please check out YouTube to get these all down again. I have to keep going because I only got 2 minutes and I got 4 more things to do. All right, so the other one is if parallel lines, then alternate exterior angles are congruent. So again, you guys are just gonna have to come here and finish your notes, because 50 minutes is just not enough time. So it's on the outside. So that would be like this, and this, and this, oops, and this. Okay. I'm not, shoot, I have to do consecutive interior. Okay. So if I'm gonna go over a little bit, guys, in class. So consecutive interior angles are supplementary. I'm so sorry. I'm going to be going over just a little bit. I have 2 more to do after this. Okay. So consecutive interior, what do those look like? That would be, so if I had A and B, that would mean angle A plus angle B would equal 180 degrees. Okay, if I had C and D, angle C plus angle D would equal 180 degrees. And I'm really sorry, guys. I know this isn't ideal, and I know I'm going too fast. Just leave space in your notes. Come back, fill in your notes. I'm really sorry about that. And then the last two is this, vertical angles. So vertical angles, to do a picture here, it's just an X, right? And if I labeled this A, B, C, and D, angle A would be congruent to angle C, and angle B would be congruent to angle D. So that's vertical angles. So it's just an X, opposite angles are congruent. In and X are congruent. And then the very last one is linear pair. So a linear pair is a straight angle split into two. So angle A plus angle B would add up to 180 degrees. So again, guys, I'm sorry that last bit went really quick. This will be on YouTube momentarily after next period. I'm sorry that I had to go so fast. The important thing to remember before you leave today, your homework assignment is on big ideas, and it's 5.2, so it's going to be a lot of congruent things. There's going to be one proof, and I tried to put down all these different reasons there. If you guys need help, please email me or come to my office hours. I have office hours tomorrow morning from 6:35 to 8:50 in the morning. You could come in the morning, get all your homework done, and not have to worry over the weekend. You could just have